For our final screencast on the mole, we will consider a relatively brief topic, and that is percent composition. Anytime you have a substance, it can be analyzed in terms of its mass percent of each atom, and you should come up with numbers. Back in the day, any scientist who was creating new substances, if they wanted to publish the properties of those new substances, they had to submit them to some lab, like, I don't know, Galbraith Labs was in Kentucky, was a cheap one. I think it was only like $15 a sample. And they would burn that sample up and give you its mass percent, and if it matched within, I think it was less than 1% what it was supposed to be, then you could publish it and it would agree, and therefore it would be publishable material. Oh my God, what a pain in the neck that was. Anyhow, this is percent composition, screencast 9.6. What is the key to solving these problems? Let's take a look. We'll go ahead and solve it. Percent composition means the mass percent of each element in a substance. Let's take a look at water, for example. Here it is, and if we look up the molar masses, you'll recall that each atom of oxygen is 16 times as heavy as each atom of hydrogen. Remember that picture with the huge oxygen atom and the little hydrogen atoms? Using these molar masses, it's easy to do, but the key is to assume a mole. That makes it very easy. Can you see how a mole, which is 18 grams, must be 16/18ths oxygen and 2/18ths hydrogen? I hope you can, because we're going to stop right there. See? Water is 16/18ths oxygen. It's an easy matter to make that a percent. 16 divided by 18 times 100 is 89. The rest is hydrogen. You could do 2/18ths times 100 and get 11, or you could just be lazy, like I usually am, and you can say the rest, 11%, is hydrogen. It doesn't show up here, but if you want to, if you're worried about getting this right, try ammonia, NH3. You should find that it is. And try it first before I give you these answers. Pause it right now and see what you get. For NH3, I get that it's 14/17ths, that is 14 for nitrogen, and 3, that is 1 for each of the hydrogens, 14/17ths nitrogen and 3/17ths hydrogen. Convert those to percents and you should have the answer. This ends Unit 9, the mole.